Hey, it's Kevin Wallace again. We're about to take our final look at the OSI stack. We've been going through several videos talking about the lower layers, the physical layer where we have bits, that's the protocol data unit, the data link layer where we have frames, the network layer where we have packets, or we could say datagrams, and the transport layer where we have segments. There are clearly defined protocol data units at each of these lower layers. However, we're about to venture in this video into the upper three layers, and this is where it starts to get a little bit fuzzy. People start to get more challenged when we get into these upper three layers because it's sometimes difficult to point a finger at a protocol or an application and say, yeah, this is a session layer protocol versus this is an application layer protocol. And the reason for the confusion, the reason that this is so foggy in our minds sometimes is what we said back in the first video on this topic, and that is this stack, guys, it was not intended just for TCP/IP. This was intended to be a very generic model that could apply to a variety of routable protocols, not just TCP/IP, and maybe some protocols that weren't even routable. And because it is so generalized, sometimes it's hard to put a specific IP component into one of these layers. For example, at the transport layer, we mentioned that we were going to use a port number to point to an upper layer. We talked about that in the previous video, and we would point to it maybe using a TCP port number or a UDP port number. Well, if that TCP port number is 1720, well, that would be pointing to a session layer protocol called H.323. However, if that port number were TCP23, we might be pointing to Telnet at the application layer. You see, when we point up from the transport layer, we're not quite sure where we're going next. We might not even go to the session layer for a particular communication flow. So I want you to realize that we don't have to necessarily fully populate these upper three layers. It's like we said in the first video. This is a reference model. It's not a reverence model. But let's take a look in general at what goes on at these upper three layers, beginning with the session layer. The session layer, as you can imagine, is responsible for sessions. Setting up, maintaining, tearing down a session. What happens when we set up a session? Well, here, we might negotiate parameters for this session. We might assign identifying numbers to a session. I teach a lot of voice over IP courses, so one of the things that comes to my mind is when you set up a voice over IP phone call, you negotiate parameters such as what port number are we going to use for the duration of this phone call? What codec, what way of encoding voice are we going to use? What rate are we going to use for fax transmission? That's just one example, but that's something that might be agreed upon when we're setting up a session. Maintaining a session involves the actual work of transferring data back and forth. And if a session gets torn down, it involves reestablishing that session and maybe even acknowledging receipt of data in addition to the acknowledgments that we get at layer 4 at the transport layer. And tearing down a session obviously is notifying all parties involved that the session is over, and a session can be disconnected by both parties in the session mutually agreeing that the session is going to be torn down. And again, a variety of protocols can do that session teardown. Let me give you one outside of the voice over IP world that comes to mind at the session layer, and that is NetBIOS. That's a term we hear a lot in networking, but a lot of people don't really understand the history of NetBIOS. NetBIOS is a session layer protocol. It stands for Network Basic Input-Output System. And NetBIOS, it's what's called an API, an Application Programming Interface. To give you a bit of a history lesson, back in the early 80s, I think it was around 83 or so, IBM had an early LAN technology. Their LAN was called PC Network. The IBM PC coming out just 2 years before that. Well, IBM came out with the PC Network LAN technology, and IBM needed computers to talk to one another on a LAN, and the protocol that they went with was NetBIOS. NetBIOS was fairly limited, though. As I recall, it could only support about 80 computers on a LAN at one time. That was a little bit limiting. And later, IBM got more and more into more advanced LAN technologies like Token Ring. And Token Ring obviously needed to span more than just 80 clients, so there was an enhancement to NetBIOS, and it was called the NetBIOS Extended User Interface, which we nowadays call NetBEUI. NETBEUI. NetBEUI is the way that's pronounced. Just a couple of other references for the session layer. Things like NetBIOS and NetBEUI. Protocols that go back more than a couple of decades. And remember I was talking about when we point up from the transport layer to one of these upper layers, maybe we don't even go to a session layer. Let me give you a personal preference before you continue. There's another stack aside from the OSI stack. It's called the TCP/IP stack, or some people call it the DoD, the Department of Defense stack. But with the DoD or the TCP/IP stack, we don't have this ambiguity as to which upper layer protocol that we're going to be pointing to next. You see, with the TCP/IP stack, the three upper layers in the OSI model, they're consolidated into one generic application layer. Personal preference, guys, I like that better. And the reason I like that better is pretty much any network we're dealing with today is IP-based. It's based on TCP/IP's suite of protocols. So why not? Why not use something like the TCP/IP stack as opposed to the OSI model, because it's a lot more specific, and again, there's the lack of ambiguity as to which of those upper layers are we pointing to next after we leave the transport layer. But it's important for certification and to understand a lot of the literature out there to understand these three upper layers of the OSI model. So we will trudge on. We've talked about the session layer. Let's move up to the presentation layer. The presentation layer is responsible for things such as the formatting of data, and that might involve the encrypting, the scrambling up of data so it can be sent securely across the network. First, let's talk about data formatting. The classic example at the presentation layer for data formatting deals with text formatting. There are different ways of representing text. There is the ASCII approach. That's ASCII, which stands for American Standard Code for Information Interchange. And there's another way of representing text called EBCDIC. These are terms that go back a few decades. EBCDIC stands for Extended Binary Code Decimal Interchange Code. Yes, I had to look at my notes for that one. But EBCDIC and ASCII, those are a couple of different ways of representing text. And if one computer is speaking ASCII and the other is speaking EBCDIC, as just one example, we might need to convert between those two. Or in the voice world, where I spend a lot of my time, we might need to convert between different codecs, different coder-decoders, so one voice stream can be converted into a format that can be understood by the IP telephone at the far end. Next, let's talk about encryption. Encryption implies that we're going to scramble up data and send it across the network in a way that it can be unscrambled by the recipient. And if anybody were to intercept it during the transmission, a malicious hacker, for example, they would not be able to descramble. They couldn't unscramble it themselves. They might be missing key information, literally key information, because there's an encryption key that's often used by both ends in the conversation to encrypt and to decrypt the communication. A couple of things going on at the presentation layer. Finally, guys, we finally reached the pinnacle, the application layer. And there's actually a good bit of confusion at the application layer. It's a very misunderstood layer. The concept that an end user application, for example, Microsoft Excel, lives at this layer is incorrect. We're not saying that your actual end user applications, as you know them on your computer, live at this layer, but rather it's the services that support those applications. For example, you might have an email application on your PC, but Microsoft Outlook is not at the application layer. But the underlying email service, which admittedly does use protocols from different layers of the stack, but that generic service that we call email, that would be considered to live at the application layer. You might be able to open a shared folder on your computer's desktop and access files from a server. That's a file sharing service. That's considered an application, a file sharing application. That service, that generic service, would be considered to live at the application layer. But something else that we often don't think about up at the application layer is service advertisement. Some network devices, maybe printers for example, they might periodically send out an advertisement making their availability known to the network. Or they might make their availability known to some sort of a centralized network directory like Microsoft's Active Directory, which could then be queried by other network devices to say, Are there any printers available on the network? We might look in Active Directory, for example, and we say, yes, there sure is. And the reason we know that there's this printer available on the network is that printer had advertised its service to Active Directory, and that process is considered to take place at the application layer. Well, guys, that is going to, at long last, wrap up our discussion of the 7 layers of the OSI model. And remember our memory aids from the very first video, our intro video. We had the acrostic of, please do not throw sausage pizza away. That's a bottom up. That's a physical layer through application layer way of remembering with that acrostic. The P in please reminding us of the P in physical. The D in data link reminding us of the D in do. And the N in network representing the N in no. And transport, throw, session, sausage, presentation, pizza, and application away. If you want to go from the top down, you could remember the acrostic of all people seem to need data processing, whichever one works best for you. This is going to show up in a ton of literature throughout your network career, and regardless of which direction your network career takes you, whether it's into security or into IP converged communications or into data center or into wireless or into route switcher or whatever area is of interest to you, this is a cornerstone concept, guys. And if anything is still a little bit fuzzy to you, I encourage you to go back and review any of the preceding videos because this is indeed foundational material. Hope you've enjoyed it, and we'll see you back soon for another training video.